So looking at this, we are now graphing systems of inequalities. So in my previous videos and in this unit, you've been working on system of equations, which we've done graphing, elimination, substitution. So now looking at systems of inequalities, we've graphed inequalities before. So when we're solving an inequality, we don't need to do the elimination or substitution. What we're going to be doing is we're just going to be graphing. So I do have some blank graphs here, but we need to make sure we review some of these concepts. So remember, we have boundary lines, and this is the way you're going to be graphing these lines. So remember, if you have just a less than or a greater than sign, when you connect those points, it's actually connected by a dotted line. And then if it's equal to, it's going to be a solid line. Okay, so our boundary lines, you have to look if it's less than or greater than, if it's dotted. If it's equal to, it's going to be that solid line. And then those half planes, remember, with inequalities, we shade the graph because we have so many different numbers that are greater than 5, or so many x values that are less than -1. So we have to be able to shade the graph because we have more than one answer. So remember, if it's less than or equal to, we're going to shade below the graph. If it's greater than or equal to, you actually shade above the graph. Okay, so those are the things that we're looking at concentrating on when we're graphing these inequalities. So when we're looking at our first ones, if you notice, we have some either horizontal or vertical lines. So we're going to be graphing these first ones. So if I graph, let me get a different color here. If I graph x is less than or equal to 6. So remember, if I have an x and I don't have a y value, that's a vertical line. So I'm going to go over to 6, and it's going to be a solid line straight through 6 because it's equal to, so I'm doing a solid line, and then I'm graphing this. So looking at this one, alright, so looking at this, if it is less than or equal to, so all the x values that are less than or equal to 6 are actually going in this direction. So I'm going to use a highlighter. We're going to highlight all of the values that are less than or equal to 6. So there's that first equation graphed. Now we're going to graph the second one. So looking at this one, y is greater than or equal to -2. So again, right here, greater than or equal to that -2, this is a horizontal line, and it's solid because it's equal to, so that's right there. So there's that y is greater than or equal to -2. And now this one, I'm going to be shading above because this says y is greater than or equal to -2. So I'm going to be shading everything above this line. Now, for our system of inequalities, if we notice, like right here, you see how my colors merged? I'm using a pink and a yellow highlighter. So right here, I got a little bit of an orange color. That's actually your whole solution set. So when you're graphing systems of inequalities, your answer is actually an entire section right here. So this entire section, that's your solution set, is that entire area. So basically, you're looking for where your colors overlap. So when I ask you to solve a system of inequalities, you just leave your answers and make sure they're graphed correctly. You don't have to point out that this is the solution set. You can if you want to, but you're looking for where that color overlaps. So basically, this whole area right here would be your solution to that inequality because that's where those colors overlapped. Okay, so let's look at another one right here real quick. So y is greater than 5, again, horizontal line because it's just a y. Now it says greater than, so I'm going to use a dotted line. It's not equal to. And greater than 5, that's all my values that are going above the line. So there's greater than 5. And then x is less than -1. So that's my vertical line going straight through here. And x is less than -1. That's all the values that are over here. And the highlighter's starting to run out. Might have to use a different one here in a second. Okay, so there's my graph for my inequality. So looking at my solution set here, this is where those colors overlap. So that's my solution set. So a little bit different from what we were doing with regular systems of equations where we would actually get one ordered pair that was a solution set. For systems of inequalities, you get an entire section. Okay. So let's look I have to move it over a little bit. Let's look at these two. So looking at this, we'll have to do a little bit more work because now this one, I'm good. So this one we can actually go ahead and graph and get that out of the way. So my y-intercept is at -3 right there. My slope is 1/2, so remember I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. Okay, and it's just looking at this one, it says y is greater than, so when I connect it, it's going to be dotted lines. Oops. There's my dotted line, and then if it's greater than this, we are going to shade above the line. So I'm going to use a blue highlighter this time, so my yellow one was dying on me. So there's that line. Now for my other equation, I actually have to do a little bit of work first. So looking at this one, I've got to get y by itself first. So first thing, I would move that x over. If it's a -6 on this side, remember it becomes a +6 on the other side. And then they're multiplying by 3, so I'm going to take that and divide everything by 3. So I get y is less than or equal to 2x plus 4. So that's my equation that I'm going to graph for this one. So my y-intercept here is at 4. And then my slope is 2. So I'm going to go up 2 over 1, up 2 over 1. And this one's actually going to be a solid line because it's equal to. So there's my solid line. Now all I have to do is shade it. So looking at this one, it does say less than or equal to. So remember, that's everything that's below that line. So when I color on this one, it's going to be everything that is below that line. So that's what your answer should look like. And using these two colors, I use blue and pink this time. So you see that darker color right there? It's almost like a purplish color. So that's your solution set. Okay, so that's all of the points that these two inequalities have in common. So that's how you would leave your answer. Let's try another one here. Again, this one already graphed for us, already done. So let's go down to -2. And my slope is 2/3, so up 2 over 3. Up 2 over 3. And again, greater than, so I'm going to do a dotted line. And then everything that is greater than that line is shaded above. So there's that first one. Again, first equation, I did have to manipulate a little bit, so I got to get that 3x over to the other side. So it's a positive, so when I move it to the other side, it's going to be a negative. So graphing this one, I'm starting at 1. And then because I have a negative slope, remember I'm going to go down 3 and over 1, down 3 over 1. And it is equal to, so that means I have a solid line. It's equal to. And then everything that is less than this line, so everything less than that -3x plus 1 is going below the line. So that would be everything on this side. So again, you can see my solution set is this darker area right here. Okay, so for graphing systems of inequalities, really all you're doing is just graphing two equations, make sure we know what type of line to draw and where to shade. Now looking at these two, you can still get a no solution or infinite solution, and I believe that's what these are examples of, so let's kind of work through them and hope that they are. So looking at this, I need to get both of these, I need to get y by itself. So here I would move the x over first. And that'll be a -x plus 4. And then I have to divide everything by -4. Now be careful right here. Remember, with inequalities, if you divide by a negative, this sign flips. So since I'm dividing by a -4, this greater than or equal to becomes less than or equal to. And that's just going to be a 1/4 x minus 1. All right, so looking at this one again, make sure you flip that inequality sign when you divide by a negative. So graphing this one, you're going to start down here at -1, and then your slope is 1/4. So you're going up 1 and over 4. it's equal to, so when you connect them, we're going to do a solid line. And then it's everything that is less than or equal to this line. So when you color it in, remember, because it's less than, you're going to shade everything below the line. And then solving your other one. Got to get y by itself. So again, move this x over. Now this one, it's a negative x. So when you move that x over, it's going to become a positive x. And then divide everything by 4. So I get y is greater than 1/4 x plus 2. So remember, we didn't need to switch our sign on that one because we didn't divide by a negative. So graphing this one, I'm starting up here at 2. Then my slope is 1/4. So I'm going up 1 over 4. And it's going to be a dotted line because it's not equal to. And then this one is greater than or equal to that line, so that's going to be everything that's shaded above that line. So now looking at this, remember when we're graphing systems of inequalities, you're looking for the shaded part that they have in common. So as soon as we started to get these equations into slope-intercept form, you should have noticed that right here your slopes are the same, so those are going to be parallel lines. And now looking at this, just because they're parallel doesn't mean it's going to be a no solution, but if I look at the shading, this one was greater than, this one was less than. So they actually don't share a common area, so that's going to be an example of a no solution. So if they don't have anything in common in that shaded area, it's going to be a no solution for that problem. Okay. And now looking at this last problem, getting these y's by themselves, if you notice, it's pretty much the same equation except for this number over here is a little bit different. So when I move this x over, it's going to become a negative x. And then I'm going to divide everything by 2. So I'm going to get y is less than or equal to negative 1/2 x plus 3. And then this one I'm solving the same way. It's just instead of a 6, I have a negative 2 there. So divide by 2. And you still get the negative 1/2 x, but right here when I divide by 2, you're going to get a negative 1. Okay, so now we've got our two inequalities, and graphing this one, I'm starting up here at 3, and then my slope is a negative 1/2. Remember, you go down 1 over 2 for that, and it's equal to, so it's going to be a solid line. And then everything that is less than or equal to this line is going to be shaded below. And then graphing my last line right here, I'm starting at negative 1. And then I'm going down 1 over 2. So they still have the same slope. They're still going to be parallel. But when you graph this one, okay, this one is greater than or equal to that line, so you're shading everything above. Okay, so looking at this, even though they turned out to be parallel lines, just like we talked about in the last one, they're still parallel lines, but like we said, just because they're parallel doesn't mean it's a no solution. This one was a no solution because they didn't overlap anywhere. This one they do overlap, so they do have this common area, so that has a solution set right here in the middle. Okay, so key things to remember when you're graphing or solving systems of inequalities. Make sure you know what type of line to graph and where to shade it. And remember, we're not getting an actual number answer. Your solution set is the shaded part where they actually overlap. So wherever those two colors cross over and make a new color is where your solution is going to be for the system of inequalities.